Namaste students, welcome back to my channel. In our previous video, we have studied about the preparation and properties of ammonia. Now, in this video, we'll talk about the properties, preparation and uses of different oxides of nitrogen. In our previous video, we studied that due to strong electronegativity and a strong tendency of nitrogen to form p-pi bond with the oxygen, nitrogen form a number of oxides with oxygen in which the oxidation state of the nitrogen is ranging from +1 to +5. We have studied this thing in our previous videos. First, if I talk about N2O in which the oxidation number of nitrogen is 1, NO in which oxidation number is +2, N2O3 +3, N2O4 +4 and N2O5 +5. While the other members of this family are not able to form this kind of too many kind of oxides with oxygen because of their less electronegativity and less affinity to form p-pi bond. So today our topic is oxides of nitrogen. We'll study the different oxides of nitrogen, that how we can prepare those oxides, what are the properties of those oxides, what are the different structures of those oxides. Now we have 5 oxides of nitrogen. First one is N2O, second one is NO, third one is N2O3, fourth one is N2O4 and the fifth one is N2O5. Now we'll study these oxides one by one. First we will take N2O, which is also known as laughing gas. So the formula of laughing gas is N2O. Now what is the oxidation number of nitrogen in N2O? The oxidation state of nitrogen is +1. Oxidation state of nitrogen is +1. Now we will talk about the preparation of N2O. We can prepare N2O by 3 methods. What are those methods? First one is the thermal decomposition of ammonium nitrate. Now what is the formula of ammonium nitrate? NH4 NO3. This is ammonium nitrate. When it undergoes thermal decomposition, means when we apply heat on this particular substance, then it decomposes to give N2O plus H2O. So this is our first method for the preparation of N2O. Now second method, I'll use nitrous acid. This one is nitrous acid. HNO3 is nitric acid and HNO2 is nitrous acid. So when nitrous acid reacts with hydroxylamine, NH2OH, this compound we have studied in the oxidation state, where we studied that beside -3 oxidation state, nitrogen also shows 2 minus oxidation state, and one is -2, another one is -1. -2 is hydroxylamine and -1 is hydrozoic acid. So HNO2 plus NH2OH on heating, it gives N2O plus H2O. So this is our second method for the preparation of N2O. Now if I talk about third method, when I heat nitrous acid with HN3, this is hydrozoic acid. This one is hydrozoic acid. Then also it gives NO2 plus H2O plus N2. So here these are 3 methods with the help of which we can prepare the laughing gas. Now we'll study the structure of N2O. What we'll study? We'll study the structure of N2O. Now the structure of N2O is basically not a single structure, because a single structure can't able to explain the all property of the N2O. all property of the laughing gas. So we get more than one structure, and that we known as Lewis dot structure, that we known as resonating structure. So we get the resonating structure for laughing gas. And what are those two resonating structure? First one is N, double bond N, double bond O. Here it is negative, and here it is positive. Clear? And it gets converted into this electron will jump here, and this electron will go here, so it becomes O, N, triple bond N. Here it is positive, and here it is negative. So these two are the resonating structure of laughing gas. These two are the resonating structure of laughing gas, because a single structure can't able to explain the whole properties of laughing gas. Now we'll study the properties of laughing gas. We'll study the properties of laughing gas. What are the different properties of laughing gas? First of all, it is a colorless gas. Colorless gas, and it has no effect on the litmus paper, hence it is neutral. So first of all, it is a colorless gas, means it has no color, and its physical state is gaseous at room temperature. So it is a colorless gas, and it has no action on the litmus paper, that's why it is neutral. Next property, in this property we are dealing with physical as well as chemical. So we are not taking physical properties separately and chemical properties separately. We are dealing with the physical as well as chemical property under the same topic. So colorless gas and neutral. So colorless gas is a physical property, whereas neutral gas is the chemical property. Now when this N2O reacts with sodium amide, that is NaNH2, it gives NaN3, that is sodium azide, plus H2O. What it gives? Sodium azide. This one is sodamide, means sodium amide, and this one is amide. So sodium amide, and this one is sodium azide, because this one is azidine, Azide. So this is azidine, sodium azide, and this one is sodium amide. So when N2O reacts with sodium amide, then we get the sodium azide. And in our previous video, when we studied about the preparation of dinitrogen, we studied that by heating sodium azide or barium azide, we get the purest form of the dinitrogen. So here we get the reactant for the preparation of the purest form of the nitrogen. So N2O, when reacts with sodium amide, it gives sodium azide, and the byproduct is water. Now if I talk about the temperature dependency of N2O, means up to which temperature it is stable, up to 873 Kelvin it is stable. Means it decomposes when the temperature is above 873 Kelvin and decomposes into N2 plus O2. So the next property, if I talk about the next property, my next property is, I'll write here the property that N2O on heating above 873 Kelvin, means when the temperature is below 873 Kelvin, it remains N2O. But as soon as the temperature reaches up to 873 Kelvin, it decomposes to give N2 plus O2. So this one is also the property of N2O. So N2O, laughing gas. In this, the oxidation state of nitrogen is 1. Preparation by these three methods: structure, 2 resonating structures, and properties: colorless gas, neutral gas, when reacts with sodium amide gives sodium azide, and at above 873 Kelvin undergo decomposition. Now if I talk about the use of N2O, so N2O is used by the dentist as an anesthetic for minor operation, not major operation. If they are doing the minor operation, so they'll use this compound as an anesthetic agent. So these are the preparation, properties, structure, and uses of first oxide, that is N2O. So N2O is done by us. Now we'll move to our next oxide, that is NO. That one is NO, which is known as nitric oxide, Nitric Oxide. So here it is NO. It is known as nitric oxide, and in this the oxidation state of nitrogen is +2. In this the oxidation state of nitrogen is +2. First of all, we'll talk about the preparation of NO. We'll talk about the preparation of NO. Now, NO also can be prepared by the 3 methods. NO can also be prepared by 3 methods. First method is when we react NaNO2, that is sodium nitrite. It is ITE. When we react sodium nitrite with FeSO4 in acidic medium. When we react sodium nitrite with iron sulfate in acidic medium, then we get Fe2SO4 whole thrice. Then we get Fe2SO4 whole thrice. Similarly, NaHSO4 plus H2O plus N. This we get. Means NaNO2 when reacts with FeSO4 plus H2SO4, then it gives Fe2SO4 whole thrice plus NaHSO4 plus H2O plus NO. Now our second method is when we react copper with dilute HNO3. Here the dilute word is very important in this preparation. Why? We'll study later on. Copper plus HNO3. When copper reacts with dilute HNO3, then it forms CuNO3 whole twice plus NO. Then it forms NO and the byproduct is CuNO3 whole twice. And the third method, which is very important, that we have discussed earlier also. I hope you get to know where we have discussed earlier. When ammonia reacts with excess of air, when ammonia reacts with excess of air in the presence of platinum or rhodium at 500 Kelvin, then we get NO plus H2O. And this is the base, means this is the first step for the preparation of an important compound by a process. I hope you get to know that which process I am talking about. So NH3 when reacts with excess of oxygen in the presence of platinum and rhodium at 500 Kelvin, it forms NO plus H2. So these are 3 methods with the help of which we can prepare nitric oxide. Now we'll discuss the properties of nitric oxide. We'll discuss the properties of nitric oxide. Now if I talk about the properties of nitric oxide, before properties, first of all discuss the structure. First we'll discuss the structure, then only you understand the properties. So structure, in our 11th class we studied about the octet rule, and we also studied about the limitation of the octet rule. In the limitation of the octet rule, there is a one point, that is odd electron system compounds, in which it is given that we have certain molecules in which a bond is made up of 3 atoms. We have certain molecules in which a bond is made up of 3 atoms, or we have certain molecules in which the lone pair doesn't present in the pair form, means the number of the electrons which are left in a particular element, they are in odd number. So this is the example of that limitation. Now how this is the example of that limitation? N double bond O. This one is first structure. Now the number of electron in nitrogen 3, means not pair, or we may write it as NO, negative, positive and 1 electron. So this is the structure of NO. This is the structure of NO, in which the nitrogen contain odd number of electron. In this structure, nitrogen has 3 electron, and in this structure, nitrogen has 1 electron. So this structure is an exception for octet rule. Means this structure is a limitation of octet rule. Now, if I talk about the properties, first of all, this nitric oxide is a colorless gas. First of all, this nitric oxide is a colorless gas. Clear? Second thing, if it is present in the solid or liquid form, means if we compress, if we decrease the temperature of, or if we increase the pressure, then it get converted into solid or liquid state, and when it converted into solid or liquid state, then it converts into N2O2 form. Means it is present in the dimer form when it is present in the solid and the liquid state, not in the gaseous state. In gaseous state, it is like this only, that is NO. But when it get converted into solid and liquid state, it form a dimer. And due to the formation of the dimer, this electron no more single. Means now we get the paired electrons. So if I talk about the gaseous phase of nitric oxide, in gaseous phase, nitric oxide is paramagnetic because it contains unpaired electrons. But in solid and liquid phase, it is diamagnetic because all the electrons are paired. But NO shows its property in the gaseous form. That's why we studied all the property in the gaseous form. Clear? So we write here that yes, NO is paramagnetic in the gaseous state. This we have to mention, because in the solid and the liquid state, when we convert this into solid and liquid state, it no more remain paramagnetic. It becomes diamagnetic. So we have to mention that NO, what we have to mention, NO is paramagnetic due to the presence of unpaired electron in gaseous state. In gaseous state, it is paramagnetic in gaseous state, and due to the paramagnetic nature, it reacts very rapidly with oxygen and chlorine. Due to its paramagnetic nature, it reacts rapidly with O2 and oxygen, and when it reacts with O2 and oxygen, then it forms nitrosyl chloride. Means due to its paramagnetic nature, what it reacts with O2 rapidly to form NO2, and similarly it reacts with Cl2 to form NOCl, and this NOCl is known as nitrosyl chloride. This NOCl is known as nitrosyl chloride, and these two reactions are due to its paramagnetic nature, and these two reactions are very fast, again because of its paramagnetic nature. Now if I talk about the stability of this compound according to the temperature, so up to 1473 Kelvin it is stable, but after 1473 Kelvin it decomposes into N2 and O2. So we can write that NO above, on heating above 1473 Kelvin, get converted into N2 plus O2. Means decomposed into N2 plus O2. Now there is a very important property of nitric oxide, that out of all 5 oxides of nitrogen, this one is the only oxide of nitrogen which behave as both oxidizing agent as well as the reducing agent. It acts as both oxidizing agent as well as the reducing agent, while other don't have this property. Only this oxide have oxidizing as well as the reducing property. Now how we get to know? With the help of two reactions, we get to know, yes, this compound has both the property, that is oxidizing as well as the reducing. And what are those two reactions? Those two reactions are KMnO4 plus H2SO4 plus N O. It gives, what it gives? K2SO4 plus MnSO4 plus H2O plus HNO3. Now here the oxidation state of nitrogen is +2. Here the oxidation state of nitrogen is +2, and if I calculate here, its oxidation is +5. So it itself undergo oxidation. So here in this reaction, it acts as a reducing agent. It acts as a reducing agent. And if I talk about the second reaction, that is SO2 plus H2O plus NO. If I talk about this reaction, that is SO2 plus H2O plus NO, then one thing it formed, that is H2. First it formed H2SO4. H2SO4. Now here, if I talk about the oxidation state of sulfur, the oxidation state of sulfur here, it is +4. And if I calculate here, it is +2 plus X minus 8. So X equals to +6. +6 plus 4 to +6 means it undergoes what it undergoes? It undergoes oxidation. It undergoes oxidation means itself it get reduced. So here it acts as an oxidizing agent and itself get converted into N2O. Itself get converted into N2O. Here the oxidation state is +2. Here the oxidation state is +1. So itself it get reduced into N2O and act as an oxidizing agent. And act as an oxidizing agent. So NO is the only oxide of nitrogen which shows both the properties, that is oxidizing as well as the reducing property, oxidizing agent as well as the reducing agent. And because of the paramagnetic nature, this NO reacts with many transition metals to form complexes, and those complexes are very useful for us. So what is our next property? That due to the paramagnetic nature, it reacts with transition metals and form complexes. And those complexes are known as nitrosyl. Those complexes are known as nitrosyl. Two important nitrosyls are FeH2O whole 5. FeH2O whole 5, NO 2 positive, and FeCN whole 5, NO Na2.2H2O. These two are known as nitrosyl. These two compounds are known as nitrosyl compounds. In this, the NO is attached with transition metals. So nitrosyl NO, that is nitric oxide, easily combined with the transition metals to form complexes, and these complexes are very useful for us. Like if I talk about this complex is used in the detection of sulfide ion. Sulfide ion. Clear? And if I talk about this complex is very interesting. Why? Because if we talk about iron, in all the salts of iron, we have studied that whether the oxidation state of iron is +2 or the oxidation state of iron is +3. But in this complex, the oxidation state of iron is +1. The oxidation state of iron is +1. Why it is +1? Because one electron, that unpaired electron which is present in NO transfer its one unpaired electron to iron. NO transfer its one unpaired electron to iron. So initially it is +2. But due to the transfer of the iron from NO to iron, transfer of electron from NO to iron, it becomes +1. So this is very interesting compound which is formed by NO with the metal complex, that due to the transfer of the electron from NO to iron, the iron becomes +1, and due to the transfer of the electron, this compound is colorful. this compound is colorful. So in this compound, the color is due to the transfer of the electron from NO to iron, and the oxidation state of iron is also 1 due to the transfer of the electron from NO to iron. So these two are the nitrosyl compounds formed by nitric oxide. So we have a number of chemical properties of nitric oxide, and nitric oxide is very important oxide or very useful oxides out of the other oxides of nitrogen. Now we'll talk about the third oxide, means our second oxide is also done, that is nitric oxide. Now we'll talk about the third oxide, that is N2O3. That is N2O3. N2O3. This oxide is known as either dinitrogen trioxide. One name is dinitrogen trioxide and the other name is anhydride of nitrous acid. Anhydride of nitrous acid. Now why this is known as anhydride of nitrous acid? We'll study in the properties of this compound. First of all, we'll talk about the preparation. If I talk about the preparation, it is formed from NO and N2O4. Means it is formed from NO and N2O4. Clear? Now, when we react NO with N2O4, below 250 Kelvin, the temperature should be below 250 Kelvin, then we get N2O3. So it is clear from this reaction that above 250 Kelvin, N2O3 is not stable. Above 250 Kelvin, it is not stable. So when NO reacts with N2O4, below 250 Kelvin, it forms N2O3. Now, structure of N2O3 is very interesting. Why it is interesting? Because N2O3 occur in two forms. N2O3 occur in two forms. One is the symmetric and another one is asymmetric. First one is symmetrical structure. The symmetrical structure of N2O is like this. O, N, double bond O, N, double bond O. So if I pass axis through O, or if I pass a plane through O, then I get the same structure around O. Means I get the same structure on the left side as well as on the right side. That's why it is termed as symmetric structure. But if I talk about the second structure, that one is asymmetric structure. Now asymmetric structure exists in two resonating forms. Now in asymmetric structure, it is like N, it is like, what is the formula? N2O3, so it is like N, double bond O, single bond O, double bond O. Clear? And second, here it is positive, here it is negative, or single bond O, double bond O, negative, and double bond O. Here it is positive, here it is negative. So asymmetrical form exists in two resonating structure. So N2O3 has two structures, symmetric and asymmetric, and asymmetric is also present in two resonating structure. So these are the structures of N2O3. Now, if we talk about the properties of N2O3, if I talk about the properties of N2O3, in N2O and NO, we studied that both are colorless gas. But if I talk about N2O3, then N2O3 is brown, means its color is brown, and its physical state is either liquid or solid, but not gas. Means it is brown liquid or brown solid. So its color is brown and its physical state is liquid or solid. If I talk about the decomposition of N2O3, then N2O3 on heating above 250 Kelvin get converted into NO plus NO2. We can write N2O4 as NO2. 2 cancel, so it becomes NO2 also. So NO2 or N2O4 nearly same thing. There is a little bit difference, we will study later on, but these are nearly same. So N2O3 on heating decomposes to give NO plus NO2, and N2O3 when reacts with water, this N2O3 when reacts with water, then it forms HNO2. Then it forms HNO2. It means this one is acidic in nature, this one is acidic in nature, and because of the formation of HNO2, this is known as anhydride of nitrous acid. Because of the formation of HNO2, this is known as anhydride of nitrous acid. Clear? So these are the properties of N2O3. These are the different properties of N2O3. Preparation with the help of NO and N2O4. Structure 2, that is symmetrical and asymmetrical, and asymmetrical still has 2 resonating structure, and these are the properties. Now third one is also done. We'll move to our next oxide, that is N2O4. N2O4. Now we'll study NO2 and N2O4 together. We'll study NO2, NO2 and N2O4. And this is known as nitrogen dioxide. This one is known as dinitrogen tetroxide, and it is also known as this one. This one is also known as anhydride of nitrous and nitric acid. Anhydride of nitrous and nitric acid. So first of all, we'll study the preparation of these two separately, means one by one. First, we'll talk about the preparation of NO2. We'll talk about the preparation of NO2. Now, we'll prepare NO2 by 2 methods. First of all, by the thermal decomposition of PbNO3 whole twice. By the thermal decomposition of Pb means lead nitrate. Lead nitrate on heating decomposes to give PbO plus NO2 plus O2. Now the second point is Cu plus HNO3. Cu plus HNO3. Remember something. We have studied a few time ago that Cu plus HNO3, but there we studied dilute HNO3. Here it is concentrated HNO3. So when Cu reacts with concentrated HNO3, then it forms CuNO3 whole twice plus NO2. So when we have dilute HNO3, we get NO. When we have concentrated HNO3, we get NO2. So this is the basic difference of the term dilute and concentrated. Due to the change in the concentration, we get separate product with copper. So we have these two methods through, with the help of which we can prepare NO2. Now if I talk about the preparation of N2O4, so we'll prepare N2O4 with the help of NO2. NO2 on heating, NO2 on cooling gives N2O4, and N2O4 on heating gives NO2. NO2 on cooling gives N2O4, and N2O4 on heating gives NO2. So these are the different methods of the preparation of NO2 and N2O4. Now if I talk about the structure, first if I talk about the structure of NO2, NO2, so it is bent shape, means it is bent shape like this, NO, O or NO double bond O. And if I talk about the structure of N2O4, so it is like N, single bond N, double bond O, single bond N, double bond, no, single bond O, double bond O. It is like this. Clear? Here positive, negative, positive, negative. So overall it becomes neutral. So N2O4, N2O4. So this is the structure of N2O4 and these are the structure of NO2. We can write one more resonating structure in which we can change the bond here as well as the here. Double bond, single bond, single bond. In next figure we can write at double bond and single bond, single bond. So these are the structures of these two compounds, that is NO2 and N2O4. Now we'll talk about the properties of these two compounds. We'll talk about the properties of these two compounds. Properties. Now in properties, if I talk about NO2, so NO2, if I talk about NO2, NO2 is brown color. NO2 is brown colored. It is brown gas. It is brown gas. And if I talk about N2O4, it is colorless. This one is colorless. Now NO2 is paramagnetic. NO2 is paramagnetic and N2O4 is diamagnetic. Means NO2 is brown in color, N2O4 is colorless. Means when we cool NO2, its brown color disappear and it becomes colorless. And when we heat N2O4, its color becomes brown. It is paramagnetic because of the presence of unpaired electron, and this one is diamagnetic due to the presence of all paired electrons. Now, because of the paramagnetic nature, this NO2 easily reacts with F2 or Cl2. To form nitrile compounds. Here it forms nitrile compounds, NO2F, NO2Cl. This one is nitrile fluoride and this one is nitrile chloride. The above one is nitrile fluoride and the lower one is nitrile chloride. So it is brown, paramagnetic, it is colorless, diamagnetic. Due to its paramagnetic nature, it readily reacts with these two compounds to form nitrile compounds. And if I talk about N2O4, when N2O4 reacts with water, it gives HNO2 plus HNO3, and that's why it is known as anhydride of nitrous acid and nitric acid. So these are the properties of NO2 and N2O4. So this oxide is also done. Now we'll move to our fifth and the last oxide, that is N2O5. The last oxide is N2O5. Now N2O5 is known as dinitrogen pentaoxide and anhydride of nitric acid. This is the anhydride of nitric acid. So first of all, we'll talk about the preparation of N2O5. Preparation of N2O5. Now N2O5 can be prepared by using HNO3, by using nitric acid. When we react nitric acid with phosphorus pentaoxide, then we get N2O5. So when HNO3 reacts with E4O10, then it gives H3PO4 plus N2O5. So by reacting E4O10 with nitric acid, we get N2O5. Now this N2O5 exists in the form NO2 positive, NO3 negative. This doesn't exist in this form. This exists in this form, that is NO2 positive and NO3 negative. That's why it is known as nitronium nitronium nitrate. Why this is known as nitronium nitrate? This one stand for this one, that is NO2 positive. This one stand for nitronium and this one stand for nitrate. So because this exists in this form, that's why it is also known as nitronium nitrate. And if I talk about the stability of the N2O5, then it is stable below 273 Kelvin. It is stable below 273 Kelvin. Means above 273 Kelvin it decompose. Above 273 Kelvin it decompose. So here the temperature, if I talk about here, the temperature is less than 273 Kelvin. And if the temperature is greater than 273 Kelvin, then it decomposes to form NO plus NO2 plus O2. Then it decomposes to form NO plus NO2 plus O2. And if I talk about the structure of N2O5, then it is like this. O, N, N, single bond O, double bond O, double bond O, single bond O. Or you can write it as N, O, N, double bond O, single bond O, single bond O, double bond O. So these are the two structures of nitrogen pentaoxide. So nitrogen pentaoxide can be prepared by this method. N2O5 exists in this form, that's why it is known as nitronium nitrate. These are the two structures of N2O5. And if I talk about properties, it is again colorless. It has no specific color. It is colorless, and above 273 Kelvin it decomposes to form NO plus NO2 plus O2. And when this N2O5 reacts with water, then it forms HNO3. And due to the formation of HNO3, it is known as anhydride of nitric acid. So we have studied about the preparation, properties and structures of different oxides of nitrogen, and we studied that the most important nitrogen, the most means the oxide of nitrogen which has majority of the uses, majority of the chemical property, that is our NO. So NO has a number of chemical properties, while other are useful also, but the most useful oxide is NO. So students, that's all for today. I'll see you in my next video with new interesting topics.